Hey, Coffee Compiler Club. All my regulars were missing today, so we're short to start with. But I have a new person, Yengiv. I can't say your
Evgeny.
name.
Evgeny.
And who's done a C compiler that's completely standalone from scratch, not LLVM based, that we can talk about in a minute. But we were having a conversation, and I realized it's like perfect shift for Coffee Club. And the conversation is, what happened to C++ for the last 25 years that it's gotten so slow in debug mode? So I built big chunks of the hotspot JVM 25 years ago using C++. Now it's an early version, and it had a lot of very raw, rocky features. So we subsetted pretty heavily. Most compiler teams that I know of, even to this day, subset on C++ because the feature count is infinite. And you agree that you're going to use the following set of features. One of the things that we agreed on 25 years ago was we limited templates to basically vectors, resizable arrays.
And
There
I
were a
assume one of the
handful of
reasons
other.
you had to subset C++ heavily is because you had to compile on Solaris, which didn't have a working C++ compiler.
Yeah, we used Seafront for Solaris, but for other things too. No. We were intending to be as broad spectrum as possible, so we had to pick the set of C++ features that were reliably, robustly available on all the targets we were targeting, which was a bunch. So Windows and Solaris and Linux all had to use the intersection of available, robust C++ features, which cut down big time the set of features we could use. Um, well, that's fine. So the development was build optimized for speed, build debug mode for, let's go find Yasser in here somewhere. I'll do it in a minute. Go debug mode, and then the difference in speed between optimized and debug mode was substantial. Um, 2x, 3x, worth doing totally. Um, but you could charge for it in debug mode and get to where you were going and debug things. New as of, then I turned away from C++ development and did lots of things and lots of languages and including a lot of Java stuff. 25 years later, I'm back looking at C++ development. The current state-of-the-art machine in debug mode on a modern C++ with a modern language design, doing a compiler again, it's 10x slower on a machine that's 10x faster than it was 25 years ago. So it's like slowed down by 100-fold. And now, what the hell happened to C++ that it's 100-fold slower to go debug? Um, it's just like insane. So, new guy, say your name, please. I'm just not going to get it.
Evgeny.
Yevgeny. If I say
Yes,
it enough
yes,
times, Yevgeny.
yes.
Okay, if I say it enough times, I'll get it close. It's asked like, what happened? Was it, bad code gen, language features? It's language features. New from 25 years ago is a lot more use of super fine wrapper templates, like onion thin layers, which in debug mode all turn into subroutine calls. Call, makes a 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 call. And, pretty soon you're 10, 20 line calls deep. And that's where all your time goes, is making these calls and returning from them. But the
Yeah, because
debugging experience is,
the assumption is they're all inlined.
yeah, right. And they will in Optimize, and they do. But the difference now between source code and that you read and the optimized code is now much further. So you can't bridge the gap in your head like I was doing 25 years ago when I had a little bit of this and some debug and some optimized or whatever. Now, if you're in optimized, the distance to the generated code is really bad. And if you're in debug mode, you're too slow to get to the bug. So what the hell happened here that made this debugging experience so miserable? Well, okay, so one of them is the speed in debug mode is 10x slower because of the use of the language features. The actual language feature usage for the templates is kind of, I'm reading it and looking and like they needed the people writing these template style expressions to sort of try to make their lives better, give them some structure and meaning to things, like need to stare hard at what the Java language folks did in the Java libraries in terms of readability of things. They have stuff, they're hand forcing it via templates to force inline things like if instance of trees, like switch, thing, case. I have this type. I'll use Cameron's favorite. I have a dog, and then I can get a dog type. I have cat, case, case, pet, case, bird, case, whatever. They've got the moral equivalent, but they're forcing it in line with templates. But that's not where your speed goes. You don't need to force inline. You want readability and debuggability, and you threw away all hopes of debuggability here in exchange for not actually any speed. It just wasn't worth it, and that's all over the place. So, I'm like grinding my teeth trying to debug this shit. And I'm trying to learn the code base, right? And you can't break in the debugger where you think you have an issue and you want to look because it's too slow to get there. And, if you run an optimized, you get very coarse line numbers as your best bet for where you land somewhere. It's just bad. So that's me complaining about modern C++ development. I have seen several folks, different projects that are making an effort to figure out something in between. And oh God, I know exactly how Java does it, and I know I could do it in C++. There is a pending giant project if only somebody would fund the money for it to do a fast
There,
C++. And just to be clear, Levo, who's not making it today because he has bad internet connection, uh, very much like pointed out, if we get somebody to pay, I'll do the C++ front end. Yes, Levo. I'm quoting you. I hope I don't have it quote you misquote you there. And I'm thinking, God, there's a lot of folks who need this so badly, but they're all programmers who don't pay shit for tools.
there is a OG if you want to try that flag, get some
Yeah, I have.
optimizations
Oh
with
no,
debug.
you're right. And it didn't really help. It doesn't because of the layers of inlining that have to happen. They have to happen. You lost the trackability between things. And Java does this a completely different way. They just give it up and say, I have two execution strategies. There's the fast one and there's the debug one. And if you want to go debug, you run fast until you get to the bug point, and then we flip strategies, and now you can debug totally reasonably. And when you're done and you hit continue, you flip strategies back to the fast one. And
That
in
would be so hard to do in C++ though.
nope, I 100% disagree. That is entirely within the realm of things. Everyone 25 years ago said you can't do this in any way, shape, or form. And the Java team did it, and I was a big part of that. I certainly had a lot of other help doing it, but
But wouldn't you have to like
doable.
JIT compile every like time you add or remove a debug point to do that? I like
Yeah, yeah,
C++
yeah.
doesn't JIT compile though, so that was
No,
very
you don't actually
difficult.
have to add
Well,
remove a JIT compile. No, but you could, but you don't have to. You
yeah,
just need the second strategy. So you need the byte codes for pre-parsed, pre-digested C++ that has like byte codes for every sequence point in C++ that you can step your way along through. And a strategy for flipping back and forth. And the only time you would need a JIT is if you edited something in the debugger that the compiler had optimized away completely.
Well, I'm talking about like in C++ where we have multiple state, like a sequence point does not necessarily mean that like optimization boundaries cross sequence points all the time.
Yeah, right.
So you can reorder things out of order in your sequence points. Now you have no sensible place to put a breakpoint, right?
Right, exactly. This happens in Java all the time. And of course, there's an answer for it.
To compile a new version that doesn't
No,
run things out of
no,
order.
the
no.
answer is that you have these things called save points where you have these clean boundaries where you can jump back and forth. These
Yeah,
are not everywhere, and you don't need them to be everywhere. What you would do
exactly.
is you would say, "Hey, pause now, step over to the nearest save point, and then you can go into JITland, or you can say like, oh, if I need to leave JITland, I can go to the save points to do so, or like you can go as long as you reach a save point, you can go back and forth between Interpreter and JITland,
So
and
you
then
have
these
to
are just
have
scattered.
save points, and you have to break at the save point before your
Yeah,
break point, and
yeah.
then
And once you've hit a
Yeah.
safe point, you're somewhere near the desired breakpoint, and then you single step in an interpreter up to the desired user.
Horseshoes and hand grenades.
Yeah,
You're
right.
close.
you're close
That
enough.
this is where the problem is. I guess if you have a loop that you want to like optimize,
Yeah,
you may have to put a safe point at the start of the loop, which breaks some optimizations.
Not
you would think
necessarily.
so.
You would write your optimizer with regards to the save points.
Yep.
So, for instance, like Java can unroll a loop, Java can strip mine a loop, Java can do vectorization on a loop. All of these things are possible, even with a save point in the loop. You just work like what you do is you just say like, oh, I'm willing to stretch how far I can go between save points, And like maybe that distance is like when you unroll, now that distance is like every 4 iterations, I'll check the save point.
The key here is to lower the overhead of a safe point to where you can't reliably measure it in performance. So my target goal is always like under 1%. There's so much noise in the system these days. Getting a value under 1% is nigh on impossible. No amount of statistics will get you that close. Okay, so you can't measure it. You can't tell there's a safe point. It's just fast enough. Now, how do I get it down under 1%? What's the overhead of a safe point? The common overhead is you have a bunch of debug shit that the optimizer wants to get rid of, and he spills it to the stack. And then it's just there on the stack as a thing waiting should you ever break. So he cost him some writes to the stack. There is some reordering within loop bodies where you might say, I have a stencil calculation that says load a guy, add one, store a guy. I'm doing some sort of, DAXB, SAXB, whatever. And I want to load 4 and add to the 4 and store 4. Well, after I enroll a loop by 4, then I can do that and I have the one save point. But if that's still too much overhead, then I do this unroll and jam. And I say the save point's now not every 4 iterations, it's every 400 iterations. An iteration is, 10 clocks, and every, 100 iterations or 1,000 iterations at 10 clocks per, I'm a few thousand clocks between save point checks. Okay, you can't measure the 1 clock overhead of the save point for thousands of clocks worth of looping. So again, you're down to unmeasurably low cost.
And what do you
That's-
do about when the control flow is different between the debug and the release version?
There's no. The control flow is different.
There's always
in-
a mapping between them because the save points are created when the original IR is made, and then they are preserved throughout the pipeline. At best, you can remove them, but there's no like, if you could shuffle them in some way where you would like lose it, that means that your optimizer is either written wrong or that you're like, actually, it just means your optimizer is written wrong because it means it failed to like do some like legal transformation.
Let me add a thing that I hear that I want to make sure we're clear on. In this world, there is no debug build versus optimized build. There's only the build. It is both optimized and debugged. So there is no, I compiled you in debug mode where a pound if def said, because I'm debug mode, I do this. That's not a thing. You only get optimized and debug 100% every time. And that's the one build. So you don't get different builds.
What I'm thinking of is like in this situation in C++ where you have some branch, the compiler is like, okay, this is undefined behavior. I'm not even going to look at this branch. Whereas like if you did that at debug, it would probably like not make that optimization.
No, if it's undefined somewhere, it's undefined everywhere. However, in the land of like what Java does, there's no undefined behavior. And I claim you could do that in C++ pretty straightforwardly. Just make a behavior that's reasonable for all the undefined behavior things and stick with it. It's not the end of the world. Like running off the end of an array should throw an exception. Range tick elimination works as a thing. Pay the cost. It's not that high. In fact, it's unmeasurably low for, unless you have a very kind of twisted loops, it's unmeasurably low to do range tick elimination. No undefined behavior, and now no buffer overrun bugs.
Yeah, but you can't do that in C++.
You totally can.
But C++ uses raw pointers without garbage collection.
You can make a C++ semantic that the implementation under the hood. This is what address sanitizer does, right? You have these things. They're add-ons. They have an overhead because they're not baked into the language and the support.
Right. Address sanitizer has a lot of overhead though.
It does, but it doesn't have to if you've defined it into the language in the first place. You get to do the range tick elimination thing without, an add-on and then hope that something gets optimized out. No, the range tick elimination would wipe out all those overheads. There's not all those overheads, but I think you can really reduce the count of overheads down to nothing. You could also say, I give it up and say, I'm not doing range tick elimination, it's on a flag, you turn it off, you do your raw pointers off the end of the array, your buffer overflow, you die, fine. If you want to kill yourself, you kill yourself, and that's okay. But there's no language change here. There's no issue with debug versus not the debug. If you're undefined in debug mode, you're undefined and optimized. It's a language thing. It's not a debug thing.
I mean, it's a good.
Just a reminder that someone implemented a version like this for C++ in 2019, and that was based on LLVM. There is also a version of the dynamic deoptimization implemented by the current MSVC compiler, but experiences are mixed with that one.
Yeah, let me see if this guy's alive. No, okay, your link is stale. Um, I follow the link. It says
Works
no.
for me, the Science Direct one.
Okay, let me.
I just opened it, so
Okay, I get
the
oslab.cs.tsinglet.edu.
first one, try the first one.
What first one? There's only you mean in the.
The Science Direct one. The one just above the OS Lab.
Oh, that's a different link. I thought there was just one long one. Let me see. That worked. Let me hit share. Let me hit share again.
And the other you do need Internet Archive for, unfortunately.
Right. Well, let's get rid of the dead link here. Hang on. Yes, but is this guy alive? I'm wondering if this is like able to handle big, complicated C++.
So we can just see what the second paragraph says. At compile time, the backlog generates unoptimized programs with accurate debugging
Right.
and optimized programs. And at debugging time, it dynamically replaces the execution of optimized
Right.
with unoptimized.
Yeah, this is exactly, yeah, okay. This is exactly what I'm thinking. There's two strategies and you flip between them.
Yeah, and they implemented this on LLVM a long time ago.
A long time ago,
You
right. It'd
can
have to
still
come up
open
with it.
that website on the Internet Archive. They never
Interesting.
proposed this upstream, but it has been done. I don't know
Right. So
how
it's
fast
totally
it was, what was
doable.
the overhead, but it has been done.
Okay. Yeah, I would love to see that be able to be used on this project I'm working on now. Let's see, beside the middle one was dead. This one was dead. I'm getting rid of the middle link. We're keeping the first and then the last is the new version of the book.
That's the archive. That archive still
Okay, fine.
works.
Right. Okay, so the links are valid. Okay, cool. Yes. Now, is there a way to, come here, Zoom being unclever? Fund a big, strong effort that would handle large, complicated things.
And there's also this effort from MSVC, C++ dynamic debugging. I do recall they cited the
This one's
dynamic de-optimization paper somewhere in that blog post.
okay. They're at least modern. Um, and of course, I have to compile on a Mac, so I don't get Microsoft.
Yeah, and
Now,
personally, I
now
don't know
maybe it's
what her
down to
experience
like
has been with that.
beat up the Mac folks to get their story straight. Fine.
Mac runs Windows and Linux fine.
The entire build harness for modulars I'm going to cook out to a GPU includes many pieces, and they're not on purpose, but they're accidentally very Mac tied. There would be a lot of work to make them not Mac tied. They're okay on Linux, but Windows is a long ways off. That would be an unrelated, large, heavyweight project, all about build systems and nothing to do with compilers. And the only goal for that for me would be to get a decent debugger for C++ on a compiler, on a large C++ project. All right, fine. We have definitely got a quorum. You can give me, geez, I didn't say it recent enough. You're
Yevgeny.
new.
Evgeny.
Say something about your project. 10 seconds, 30 seconds. What you're
So
doing.
basically, it's a modern C compiler in terms of standards for C17, C23. For Linux, System 5 AMD 64 ABI. There are some optimizations. I'm working on it, kind of a self-contained project from C source code to assembly and integrate with glibc, muscle, and GNU bin assembly and
Put a link in either the document or the chat because I looked at your project link. It looked interesting. It was not the LLVM.
yes,
And
it's my own implementation from
yeah.
C source code to assembly.
And then as an unrelated note, the power just went out at my house and we're powering through it on batteries and generator. Just in the last 30 seconds, I went from no power to the generator kicked in and everything's not on a UPS is rebooting. And that was just to warn you in case we fail out and go to and lose connection, but it's not. It's going. So it all worked. Fine. Penalties of living in the remote mountains. Did that hit the dock? Someone put that in the
Do you
dock.
use Starlink?
No, I have Comcast cable. And the cable guys have lines that are not, they're independent of the power lines running through the mountains. And then they have battery backed up, generator backed up batteries, whatever you call it, refresh the signal down the hill to the valley, and then you're in, Silicon Valley, and then they have their headquarters and their main things. So the cable is far more reliable than the power. In an average year, I would say the cable has gone out one time in 3 years, 3.5 years. Power goes out 4 or 5 times a year, usually in the winter during a winter storm, but not to the cable. So take your pick on why that happens.
Yeah, I noticed that as well. My internet usually doesn't go out when the power goes out, so I have it on a battery backup.
So I need batteries to keep my local router alive and a battery for my computer and monitor. And then the generator kicks in after 30 seconds or less. And then the house is powered again. So there you go. And the whole house battery guys called me. I've been trying to get a house battery for 9 months. And I have paid my money and they owe me a battery. And they finally called me yesterday and said, okay, let's schedule a time. The next available, person to come up and put your battery in will be next week when I'm at an all hands at Modular in Texas. And I'm like, I'm not there. I waited 9 months. I haven't traveled in 9 months. And the 1 week that I'm traveling in 9 months, you want to put the battery in. So another 2 weeks after that. So it'll be another 3 weeks. But they'll beat the major part of the winters. So I might have a battery this winter, and then we'll run the generator. The only reason the generator is an issue is that it's 6 times more expensive to run generator power than take it from PG&E. So if I can not run the generator 24/7 when the power is out, I would rather live off a battery and save my gas money, propane gas money. Fine, never mind. Not compilers at all. Geez. Now I'm completely distracted. We were talking about your thing here. Named after fermented milk. There's another non-compiler thing. Implements SSA. Oh,
You
there's
want to put it up
PG
on the
telling me my
screen?
power's out. You got debug mode in this thing. Yes, you have optimizations.
Cliff, you
Very
want to
basic.
share?
Very
You want to
basic.
share your screen so people and watching the
I'm
video can
just
see
pulling up.
this?
Yeah, let me do that. I'm just reading through. Was interested to see that it was a standalone, and presumably vastly simpler than LLVM, which means be much more approachable to go do things with it.
It's quite messy because I kind of started it as a different project with kind of threaded code generation. Then I transferred to SSA without rewriting much, doing a conversion. So it's quite messy inside.
Yeah,
I
that's
believe.
the normal. Your personal projects get quite messy, and you go from one to the next, and whatever's interesting. And if it's not exciting to go clean things up, you don't do it. This is like the same, very close to the set of optimizations I run in the simple project. If you're interested in seeing another way to do an SSA-based compiler, that's me just promoting simple. It's a open source optimizing compiler. Mildly optimized, not fair. Mildly optimizing compiler, SSA-based, and it's just as a compiler tutorial. Certainly, it's not doing C. It's doing a trivial language on purpose because it's not about the language, but it is about how to represent SSA and do all the things you get out of SSA. And I get a lot of things for essentially free.
Is there a reason that you decided to implement a new compiler?
A new language?
There is.
Oh, you're talking to you can get me.
For me, there is no particular reason. I just like the process. It's kind of art project to me. I'm doing it for the process itself. I want to have complete C compiler of my own, and therefore I'm doing it, and I want to have it kind of well-rounded, so it does some optimizations at least, and has debug mode. So
Yeah, I totally get it. Very cool. All right. Somebody else have something you want to bring up? What did we talked about C++. Oh, I have a minor thing. I'm doing the top-down, the optimized version of SCCP, sparse conditional constant propagation, as opposed to the bottom-up finally, and just observing that a lot of my transfer functions are not monotonic; that are only visible when you go top-down instead of bottom-up, and they're all stupid things that said stuff like, if your input's not control, then you must be dead, but your input starts at top, which is not control. And so therefore the test needs to be, say, top or control, or I need to get rid of the control type as a thing because I don't actually need it. It's just there for looks good, but it's equivalent to top, except in the SCCP algorithm, you set everyone to top to start with. And that means they're not at control or at X control, which means I need two tests.
being the optimistic pass in the
Yeah, it's
syntax?
the optimistic pass. Yeah. And it's finding funny little things that are not monotonic only when you come top down, not bottom up. And generally for, like I just said, stupid, oh, I need to check for this. Like the most recent one here, I'll pull this one up. This was a little more interesting. This is a float failure. Let me find it. Let me share it. And I have to fix my font. I had a look at this. Okay, I got the faster
Can you
font
zoom?
thing.
Yeah.
Yeah, look at that. I have to do it in every buffer. Oh, that's fine. We'll do that here. Okay, so the bottom guy is multiply, who I have not fixed, and the top guy is plus, who I did fix. Let's look at the broken guy first. So here is my transfer function for float multiply, which normally comes in with values that are given to me by the start of the universe, the parser, which are all going to be some kind of float. And I go ahead and check, make sure that you're actually a float. And then if you're constants, I'll do the multiply. And if you're not floats, then there's something broken. There's like an error case. So typically your bottom, I do a meet call on your inputs, which generally returns bottom because you have a type error in your program because your program's just broken. And I don't need to type you well or compute any optimized value. So the bottom up version says, if you made it up to a constant, you get a constant. And if you didn't, you're generally a float unless you had a bottom type, which is an error and you, whatever. So in the top-down universe, I would come in with two tops and not a high float, but a top. That would fail the you're a float test. You would now do a meet. One of the values would be top. One of the values would be something, could be exciting, like a floating point constant in this case. And then top meets constant makes constant. So he says, oh, the multiply of top and 3 is 3. Later, that top value is actually falling to floating point 5, and you should multiply 2 times 3 and get 6. But you're already a 3, and you can't go sideways to go from 3 to a 6 because that's not monotonic. So the bug is you should never have gotten to a 3. You should have stayed top because one of your inputs was top. And the fix is I put this, if you're high, either one, you're a high float. So if one of you is top and one of you is a 3, you're a high float, fine. If later the high float falls to a 2, then you pass this test and you decide, oh, I'm 2 plus 3 or whatever. So mid-hacking fixing, so I haven't fixed it in float, but that'll happen.
Yes. Yeah, I got tons of random cases like that, especially once I bumped into like adding the congruence finding stuff, because sometimes you run into cases where you optimistically started by assuming that x minus y, that x and y are congruent, and because of that, the answer is going to be 0. Yeah. But like that should only be 0 given that x and y's types can actually even like Zero is a subset of their
Yeah.
types. Like they're actually like their types don't overlap. But you also can't just say, oh, if their types at least if you have a like a range, like ranges in your lattice, you can't just say, oh, if the types aren't equivalent, they're not congruent, because there are times when one of them might be like
They could fall to each other. You have to verify
yeah,
they cannot fall to each other. Yes.
yeah, exactly.
Yeah.
And so yeah, you have to verify that they can't, because sometimes you'll have a case where they one of them goes to like 0, the other one hasn't gone to 0, and then they actually both drop to bottom,
This
but they're
is like
still
a
congruent.
this is like a fun one for the doc.
Yeah,
I was trying to write an Emacs, but let me put it in the doc instead here.
yeah, but they could both still be congruent, even if they both like don't fall exactly at the same time. Because in practice, you might have like you're running at random order, so it's possible you might see it before it's fully dropped all the way to the bottom.
I have no chance of writing this in a readable fashion in the doc here. So Yasser's working on my click thesis version of conditional constant propagation coupled with value numbering. So you have things like if x equals y or x minus y, do something, and if x turns out to be equal to y, that'll subtract to 0, and this code will be dead. Dead if x is equal to y, alive otherwise. And then somewhere in here, this code does something evilly bad, like, oh, I see, I got the triple dots, don't need that. It does something like y plus plus or whatever. It's exciting to know. And then, let's expand y plus plus out. So as soon as you do this, the congruence with x and y, fails. So somewhere above, there's a loop. Who knows what the loop's testing on? It runs for a while. Is x equal to y in the body of the loop? Well, x is equal to y in the body if x is equal to y ahead of time and not otherwise. So if up here I said x is equal to y, and I come in, then x is equal to y, so the if is false, so I don't add 1 to y. And if here I'll just do int y equals whatever, read, and int x equals read, but then I set them equal. So under this case here, x is equal to y can be proven down here. Or if it turns out that they're not equal, then this test might say, oh, I'm going to add 1 and now they're not equal. So your equality of things it depends on whatever the equality was and whatever constants are showing up already. So it's part of conditional constant propagation does this kind of a thing except without the congruences. The funny thing is that if you don't know what x and y can be yet, so I said read, but suppose there's some arbitrary calculation here and you don't know what it is. Why didn't you not collapse those, dude? Who knows what goes on in the mind of the Googleator. Now you have this funny case where maybe they're going to be equal and maybe not. And so you want to assume equality, because if you can assume equality, you can prove equality. And if you don't assume equality, you prove non-equality, right? So I'm going to assume equality. Well, can x be equal to y? Well, if x is an int and y is a string or a pointer, the answer is never. And if x is equal to something, a range, like a bool, and y is equal to a negative number, and the bool is 0 or 1, then the answer is never. But maybe if they're both interesting overlapping ranges, but you haven't figured out what they're going to be yet because you're in the middle of the algorithm, they might be a maybe. And then you want to keep the notion they could be congruent, maybe, if things settle. And and as Asher points out, yeah, you can get some bugs here. Here's my canonical easy one for what this is constant propagation, where the top-down version will find you a constant and the bottom-up version will not. Moving this into SSA form. So in SSA form, if you start with the bottom-up then the fee has to say I do a meet of the incoming value, obviously 1, and the back edge, which I don't know because I'm doing the bottom up version, and I haven't seen x2 yet. So I'm going to assume it's bottom integer. So the meet of 1 and bottom is bottom, and I have a bottom integer, and then I do, 2 minus bottom, and I get bottom. So if I assume x2 is equal to bottom, integer bottom, then here I set x2 to integer bottom, and I've hit my fixed point. I've proven it's bottom, and I lost. I finished the algorithm and I lost. Whereas if I start with it equal to top, then I say top meet 1 is a 1, and now I do math. 2 minus 1 is 1, and x2 becomes a 1, and I prove it. So this is one that specifically will win if you do the optimistic version. Specifically loses with I'm going to call constant propagation, like a constant folding.
I'm sorry. Does this pass run only like once without, like it processes the loop only once, or do you? Because I had some exposure to abstract interpretation, and there they kind of run the loop actually until it converges.
Yeah, this will converge in one iteration, 2 iterations. If you do this bottom up and versus top down, so I don't know if you know what I mean by that. That's the optimistic version is you start everyone at the top value and you run until it converges. Bottom up can be done incrementally even during parsing, and I do this literally character by character as I parse. The bottom up version says I start with something like this, but I don't know anything about it, and I'm going to assume sort of the worst. And if I can make progress, I'll do a peephole rewrite rule and change things. So constant folding be one of the peepholes. There are many, many other peepholes. But the starting point is I have a fee whose type begins with int bottom. Maybe you refer it that way. And then I do math. 2 minus int bottom. Well, it's symbolic math, so that's int bottom. Now, if you bring that around and you want to look at convergence, well, we'll get this guy up here, an int 1. So he's the happy value. You've converged now in one pass. Right? Like the result of x2 is int bottom. You come back around to the loop, go to the next iteration of the loop, hit this guy again. He computes int bottom meet 1 is int bottom, no change, you've converged. Whereas if I swap this to int top here to begin with, sorry, let me get this incorrect here. Now I do math of 2 minus int top. I'm going to go, so that's the start. The meet of 1 and top in a step. So we're going to take a step. We're going to go to int 1. Then in the next go around here, I'm going to do int 1 minus 2 is int 1. And now I converge, although it took me one more round to go get it. So this is a case where you win for doing the top down. There's a conditional version. That's the standard conditional constant propagation where you do the same thing. We have an if test that if you assume the if can go both ways, you lose. And if you assume it can only go one way, you can win and find a new constant. And that version wins a lot in large, complicated programs dealing with null pointers where people have null pointer checks. And if the value in question is null, then they get stuck with a null, or if it's not null, they get stuck not null, or whatever. So they can win if they know something about the nullness properties. And then the conditional one has the next piece in, which says if 2 values are equal. That shows up all the time. We have complicated loop nests where you have fees that were going to make things equal if they can prove that they were equal coming in the first place. So I'll do a conditional one here, maybe. But then somebody else can take over talking. But I think that the comment from Yasser, which is what I was just running into, is that these things can find bugs in the top down that the bottom up will never find. So here's a conditional one. Just if you're bottom up, the fee that you get here, assume that the back edge is x is not a 1. So if you assume assume x2 is bottom, then x1 is bottom. This test goes both ways. Therefore, the x++ fires. Therefore, x is not a 1. Therefore, you hit a fixed point where x is not a 1, where in fact that test is dead. And the optimistic top-down version finds that. So that's that piece of things. All right, I'm lecturing instead of having a conversation. I need to shut up.
No. So generally, as this goes against the program execution order, and that's why it cannot
You're
find it.
super quiet, Theodore, and I have a generator in my ear. Turn it
Oh.
up, but see if you can speak louder.
Now,
Yeah,
is
better.
it good?
Yeah, it's better.
Good. So generally, it cannot find it because it goes against of the program evaluation order.
Yeah.
That's okay.
Yeah, you have to just you're doing partial evaluation.
Mhm.
You bottom up you can do without knowing what's coming. Like if you're mid parsing and you haven't seen what the future holds,
Mhm.
and
You assume the worst. You assume
you assume the worst.
bug.
Yeah.
So I have a question. I noticed in general, like compiler optimizations have a lot of like graph transformations.
Mhm.
Are there any like programming languages that you think can do like have like specific graph transformation declarative style programming that maybe like might make these easier to write? Besides maybe, I don't know, Haskell or something.
As the actual program transformation, this is what C++ templates are doing, right?
Yeah, everyone's got their own flavor of like pattern matching,
Yeah.
which is usually limited to like trees or like DAGs, but that's like even though they're like technically speaking, there are like cyclic graph transformations, probably like a good 90% of them aren't. So if you wanted to pick up like pattern matching in whatever language, you could probably do that.
There's actually very few, I think, and one of the one I run into, but it's for graphs in general, is Graphite. So if you know Halite, which is basically a language for user schedulable transformation, someone has done something like that but for graphs, and it's called Graphite. And it allowed actually some pretty interesting optimizations when you can just schedule the order of graph traversal independently of the graph algorithm and things like that. That was actually pretty neat and had good performance for the time.
Hmm.
But that was just a DSL. Kind of like a halide, but for graphs.
Let's say PyTorch is essentially a DSL for doing
For computation graphs, yeah, right. Everything that can take O and an X in a sense too.
Right. This is building it. I want to see some examples here.
Go to the language manual,
Where do you
maybe.
see it?
Good on the website, on language manual on the left,
Let's say I'm looking at the heat maps. Look pretty exciting.
and then just scroll down. Yeah.
So parallel sum vectors. All right, these are reducing operators. This is like sets.
Oh, actually, go to the publications and go to the slides from the 2018 one. The original one. Yeah, go to the slides. And it's gonna have a nice example when it shows this side by side compared with the optimized C++.
Let me share the slides. It opened a new thing. So graphs.
Yeah, so yeah, you have like a simple example, right? And that's like the normal C++ version looks like. But then you try to optimize this, and when you keep scrolling down, you will see it. Keep scrolling, yeah, and this is more than 23 times faster than the previous one, but this is now that how it looks like.
Right, right. This is what modular is trying to do. Trying to make this reasonable.
And now if you just jump way ahead to slide 50 and then 51.
Oh, give me my slide numbers. All right.
Way ahead, slide 50 and 51.
I think he's downloading the slides. Why did you stop paging? 50, no, 48, 49,
Oh yeah,
51, 52, back up.
go back, yeah. So you see, they have just a bunch of fundamental primitives, like an apply function on edges. You can go from to source filter, and this is their PageRank example starts like that.
Yeah.
And when they want to change something like about change the order in which they update or whatever, they have this separate scheduling thing, and they're just gonna add this at the bottom. So at the end of the day, go now to like slide 60. Like this is the like one of their baseline version. Switch way to slide 60.
Yeah, I'm scrolling slowly to see what kind of things are going by when I
So you
get to
have the
60 here.
scheduling language. This is gonna be the language when you express optimization. So this thing in the blue box, now this is the baseline
Right.
algorithm specification. And now when you keep scrolling, you will see that they optimize separately. So okay, maybe I wanna have a sparse push direction. Let's put this in the schedule as a separate line. Maybe I'm gonna do this, maybe I'm gonna do that. And it's keeping it's gonna just generate different crazy C++ for you, but it's going to allow you to have very high level specification. Maybe like you're gonna have like dynamic vertex
Right.
parallelization, that's just one more line of code you add in the schedule part. So it's kind of like Halite but for graphs, I would say.
Interesting. Right.
And
There you go.
it does work.
Right, there you go. Many more. Right. Roll it in. Okay. PageRank being a good example of being complicated enough and realistic enough. Reason about iteration spaces. Yes. Okay. Let me see if I go a little faster here. I need a page down button because I get misaligned here. Why does this guy not have an obvious page down? If he does, I have to find him. Cool. Well, okay. I might have to go. There's more reading.
It's also
Auto
interesting.
tuner.
They point out like they have a lot of compilers can reason about dense iterator spaces like arrays, but they also had to implement reasoning about sparse iteration spaces because graph traversal is sparse, of course.
Right. Yes.
It's been an interesting paper, I think.
Trying to see if there's how to read the colors here.
And there has been a bunch of stuff built on that. Like the last publication is 2021, but I've never seen anything like that in like mainstream programming language. So I think there's still a lot of space
Well,
of
this would be
exploration.
picked up by the AI compiler folks. Be the obvious thing. Because they're doing all these linear algebra based transformations.
Oh yeah, there's a lot of
on
sparsity
arrays
optimization
for
too. I don't know if you have
GPU
looked into like how large language models are implemented, but if you consider mixture of experts architecture is basically a block sparsity when you have multiple feed-forward neural networks that you are basically able to split up so you don't take up all of the memory on one device or even one node. And that's sparsity. And optimizing data traffic for that sparsity, that's a sparse optimization problem. So there are a lot of interesting open problems in this area.
There you go. Probably not going to help it here. This is what we were at a second ago. Well, cool. Let me stop this. I'm staring at the doc, making sure the doc has the link in it. Lost my page. Yeah. There's going to be, I mean, there's I don't say no room for improvement. There's a need for it. There's a thing there. How did we get here? What were we talking about?
Graphs, apparently.
Sorry?
Yeah, I was talking about graphs, just if anyone had like seen any languages for
There you
graph
go.
transformations, because I think it's really useful, not necessarily in the front end, but at least in the back end, or maybe like a middle end.
Conversion between byte and int8 and uint8.
Yeah, so this is my next like topic suggestion. So I've sort of, as you guys know, or many of you know, I'm building a language. And like one of the things that I need to decide is whether, so I have a separate byte type and integer types, and this sort
There's
of,
your problem.
well, I thought about this for a while, and I eventually definitely decided that having separate byte type was better.
Okay.
But this has more to do with aliasing problems, and like aliasing analysis passes, where I don't want integers and bytes to alias for the more separate types you have, the better optimizations you get, basically, in LLVM.
So what is the non-overlapping portion between a uint8 and a byte?
So this is like, I guess starting with the motivation between having byte separated from int, this has to do with mostly the aliasing passes of LLVM, where you can say, okay, I store this as an int8 or a uint8, and therefore I can't read it back as a byte or something like that. So one of the
Therefore,
things,
it does not alias.
right? So they're non-aliasing, like different versions, and so
Well,
So you're designing your language based on shitty design of LLVM. Did I get that right?
no, because that's actually something
Wait, that was the wrong answer. So,
it gives better performance. So I would say it's not shitty because it
no,
actually it
how does
improves
it
the
give
performance.
how does it give better performance?
nothing in any of those
I'm
conversions that will make any difference to anything.
I'm
Bingo.
sorry, but it's basically what C does, and LLVM just inherited it from C standard.
C++, but
That's how.
I mean, no, I meant just C++. C does not matter in this case. They define aliasing as basically.
C doesn't have strict aliasing. Only C++
Right.
has it. C
It's
disables
it's-
it by
it's-
default.
No, they
It's-
both have strict aliasing. They just both like choose to turn it on or off depending on the compiler.
Wait, C didn't have. Hang on.
Yeah, the rules
It's-
are also in there. Like for instance, all the rules about like how a char can alias with like an integer or like a char can alias with anything. Like that's a rule that's also in C. It's just that people may or may not follow it because of like cultural reasons.
All right, I should let me.
Yeah, I can find the part in the spec.
There are bypasses in C anyway.
I
There's
think
bypasses in
I
C++ too.
to not design your language built around the restrictions of LLVM.
Well, it's not a restriction. You actually have to go in and type it out. It's like not enabled.
It's a restriction in the sense that it makes more or less performance according to whether or not you've decided this and that alias or not. Is this performance the driving thing in defining the language? Because in all these cases where the performance comes or goes, you can totally get that performance in another way.
Yeah, not using LLVM.
LLVM, I don't understand what you're talking about. LLVM is our best optimizer right now. I mean, sometimes GCC is better, but
well, it's not that it's not. It's not even that it's not the best, but the question is like, are you willing to say that forever you're just going to be bound to LLVM's decisions? Because in 10 years,
what? This has nothing to do with LLVM. This is
it does.
You're
not making a language.
No, it doesn't.
You're making
GCC
an LLVM plugin.
No, I'm not. I'm building
you just said because LLVM does this, I'm changing my language to match.
No, every compiler does.
What?
Okay, let's
no. But specifically, you're specifically doing that with LLVM.
We're gonna like let's talk about first what aliasing, like why this matters, and like this is something that's applicable not only to LLVM but also to GCC and any and
to Java, who makes great hay out of aliasing because he has strong types.
I would say
no cheating.
Scala maybe win the game here because there is an implicit conversion and you can define it in the language when you can alias the byte to int8.
But I think you can't tell the JVM byte codes. You can't tell the byte codes.
Okay.
Right. So
But-
in any case, like when I have a load from a pointer and I'm loading data, right? Like the compiler might want to know, like if I wrote data if I load data from the same memory location twice and there is a store in between those two loads,
Right.
the compiler wants to know if that store can alias the location that you
Right.
just read memory from the second time. And
Yes.
this is where like strict aliasing rules come into play in languages like C,
Right.
C++.
Okay, so just like I'm trying to encourage you to get your head out of I'm C++ only, because Java does the same thing. You got two loads to store in between. If they don't alias, wow, you can do something about it.
Right.
Yeah,
Okay.
strict aliasing only really became a term because C and C++ can turn it off. Every other language would just like consider this as part of the like strong types. Because
Well,
like if you have
no,
really strong,
all the time.
You can't turn it off in C or C or C++
like,
at least.
you could
C
turn it
you
off.
can.
You can turn it
No,
off.
the compiler
Yeah.
you can turn it off on GCC or Clang, but you can't turn it off in the language because that's not a language feature that's optional.
Well, that's technically like true, as in like it's like a language feature that is like the spec says it's mandatory. Two things. That's only half true because it's a UB feature. So technically, the spec could just say like my definition of it is to do the strong aliasing rules or the weak or strong aliasing rules. It just has to be like greater than or equal to.
When did this change? I mean, I believe you. I just don't know when it changed.
So C++ has always had strict aliasing in the spec.
No, sir.
Yes, it does.
No,
it's C++.
It had the flag, but it was never.
No, the flag is part of the compiler.
And no one I ever knew ever believed it was on by default. It was never a default.
No,
So
I think that was already in
different.
1998. I think that was in the initial 1998 standard.
That it was on by default?
It was in the standard.
Yeah, it was never on by default in any compiler.
But on by default is completely irrelevant because that is a compiler feature,
Yeah,
not part of the language.
Compiler optimizations weren't able to do much in Turbo C++, if that's what you are talking about.
So,
but
Matt,
then
So if
Turbo
none of the
C++
compilers
being
implement
limited.
something, it's not part of the language.
No, that's not true.
Thank you.
No, because like
and
something
furthermore,
could be UB.
saying initial C++ standard in 1998 is 15 years too late. So, like,
I mean, it's the only standard that ever existed. Nothing before that was standard. There was a boot by Björn Strostrup, sure, but that was not the standard. The standard is the standard.
Yeah, but like you're putting a lot of like stock in the standard as opposed to like,
and no such standard. Yeah, it was not the standard.
But the GCC developers and then later Clang developers put a lot of stock in the standard, and that's why today most of the code I write into definitely compiles with fast, and that definitely includes strict aliasing.
Well,
no one disables this in HPC. No one, not a single person ever. I think it's only the Linux developers who like to rant about the standard options that disable this in GCC in their kernel builds. Most people I run into do not disable that.
Okay.
But again, you mentioned
there is another interesting question rather than the history of strict or not strict, right? And that's choosing to make Byte and uint8 different types in order to take advantage of the aliasing that would follow, assuming you have a strong strict aliasing on.
Yes, that's kind of half the point of what I wanted to bring up, of course. I mean, I have decided for my language that I am going to be taking advantage of that distinction. But I guess the next thing was like in C++, byte and int are not implicitly convertible between each other, even if it's like int8 and byte. Those are not implicitly convertible types. And I'm thinking, should they be implicitly convertibles as values? Not by pointers, but like as the values themselves, should they be implicitly convertible?
My default answer would be no, and but I caveat that's my default answer for any implicit conversion. I think they always end up biting you.
My take is that byte and int8 should be the same type, and they're just alias names to each other.
So Cliff, I'll say that you're wrong, but you're close. So byte
they end up biting you.
Byte and uint8.
Uint8. I'm sorry, uint8.
Okay, so we're agreeing.
I meant uint8. Absolutely. Yeah, Java got it wrong. Definitely.
Yes.
So I'm personally thinking like I think they should be different types, but interconvertible. That's kind of like
maybe you don't want to have arithmetic operators on byte. If the byte is just a dump storage format, then you don't want to have someone add 1 to it for some reason, because then it's no longer a storage format.
There's another piece here, which is why only two bite-sized, unique unaliased things? Why not 200 of them? Give them a name. Hey, this is my Celsius temperatures type. This is my whatever collection of foods. This is my whatever thing. They're all bytes, but I give them, this is my red, green, blue
Maybe if the
pixels.
users want to do that, and again, that's actually a good point. If
That's
you have
a
a problem with that, if that makes language hard to use, then it's a shitty language because it doesn't support type-based programming, of course. So yeah, if you cannot have 200 domain-specific types per project because the language makes it frictional to program, then it's a really shitty language. Don't design shitty languages that make it hard to work with types, of course.
Wait,
but
sorry,
then
how many
again,
types did we say we're working with? Like
Huh?
we're talking about like renames, like renamings of like what bytes exactly?
Yeah. I have a collection of bytes that I know are red pixels. I have a
Mhm.
collection
sure.
of bytes that are blue pixels. I know they can't ever alias. Those collections are unrelated. I want to express them in a way that says I have a pointer to blue pixels. I have a pointer to red pixels. And the compiler knows they shall not alias, therefore he can optimize them.
that is actually a new type in Haskell. So you deliberately make a distinction in the type. You know that it's a string, but it's a specific set of strings or a specific set of pixels
Yeah,
or a
I have a
specific set of
specific
numbers.
collection of
And
things.
you want the compiler to treat them differently. So you have a
Right.
reason to do that.
Exactly.
So
It's very common in Haskell. It's pretty much
yes,
idiomatic. You create new type when you have a new domain.
Matt, you're
You
very
want to
soft
express it.
again.
Not everything is an int.
I couldn't hear you. You're very soft. We have sound leveling issues.
me or Matt.
Matt,
Matt,
I'm too soft? Interesting.
Yeah.
1, 2, 3, 1, 2, 3. How about now?
still
Mhm.
soft.
I want you to shout.
Yeah.
Eat the microphone.
Yeah, I'm wondering like more on this like line though of like implicit conversions.
Yes,
And
and
so-
that's why I said sorry to interrupt you, Ryan.
Let him finish
Okay,
his
fine.
question statement about implicit
Go.
conversions.
Go.
Go
Yeah.
Ryan.
Okay, so yeah, I guess my thoughts are like what are the different pros and cons of having like implicit conversion? Because like I don't really like when I've been programming in C++, like I often found that that the whole byte being not implicitly convertible to int and backwards is like kind of annoying because I'll have like a library that does like an array of char or something, and then I have this like I ended up building this like proxy type where I convert everything to a proxy and it's implicitly convertible to an int 8 or a byte or whatever, and then like I have these helpers and everything to try and like glue
Okay,
different libraries
wind it down.
together.
You found it annoying for a lack of implicit conversions.
Yeah.
But is it worth it? And if I'm making a new language, can I just say, okay, everyone use Byte for like data?
So the experience I at least have in Scala and Scala in general, that implicit conversions are really convenient until they aren't, because the magical behavior, it accumulates, and in some point, if there are too many implicit conversions, that you cannot understand anything about it, and that's why Scala brought that down and back up about a little bit and make more strict. So there are pretty use cases for that, but they really be really a niche. So that's my point on it.
It's really easy to code yourself into a situation where you don't understand the sequence of implicit conversions that are going on that got you from point A to point B, and now something's broken.
So the Scala is kind of in the middle. It allows you to define when something is convertible to something else type-wise, but this really should be used sparingly. So whenever they made sense.
So there's a link I put in the chat that sums up.
Yeah, I was looking at the chat got ahead of me with links, and I was looking at Yasser's where and when you can alias and you can't. And
But-
yours is going to be
But Ryan, what I'm going to encourage you to do, because there's no right answer to the questions, there are definitely wrong answers, by the way, but there are no right answers. But what I'm going to encourage you to do is to start from, some sort of first principles, like what's actually important to you that the language preserves or guarantees or does on behalf of the user, because you're missing some you're missing the basis for deciding some of these questions that I would expect you to already have. Like if someone, said, I'm building a language and I don't know how this particular thing, should behave, the question is, why don't you know why it should behave? Because you should have a strong opinion on a lot of these topics based on fundamental decisions, first principles, if you will.
Yeah, well, my first principle has been I'm building a language that's similar to C++, but I'm trying to make it better, basically. That's been the principle, and it's not like a highly opinionated
Don't say
language.
better. Explain a dimension on which it's better.
Really, so I'm trying to take C++ as the basis for the language, right? And taking the structure and semantics of C++, and then if there's something I think C++ did wrong, then I'm changing that. So for example, the way that you import header files and then you do all this text processing is really slow. So one of the things that I'm doing is I'm doing like modules as just the way everything is imported. And so you don't have to do that text processing preprocessor step. So macros are gone because I think those are bad. And then another thing I've changed.
Macros are bad. My language is good.
But I guess like it's like a case by case thing where I'm like, okay, I can go look at these examples of historically all the problems that macros have caused, and I'm just looking at it and saying, okay, that was a mistake. It's not a fundamental philosophy thing. It's just like, okay, we did macros, it caused these problems, it made the compilation slow, therefore I'm not going to do it in this language. I'm not keeping that part, right? So I'm looking at more of like I'm not trying to build something that's foundationally different from C++, like Rust and Carbon. They're all like foundationally philosophically different. What I'm doing is I'm like keeping the C++ philosophy, but then going, okay, that was a bad idea, and I'm okay with breaking backwards compatibility to change it. Whereas C++ isn't.
Wait, sorry,
right?
so what is the C++ philosophy exactly?
Take everything from every other language that's saying bad stuff about C++ and glue it onto C++.
So I think Ryan said C++ the good parts. I'm building a language that's like C++, but the good parts of C++.
Yeah, but what I'm trying to figure out, is like what are the good parts mean, or like what's the guiding principle behind
Ryan, if I can recommend one paper you take a look at is this paper C, Memory Object and Value Semantics, the space of de facto and ISO standards. Because this is pretty much exactly what we have just talked about. And this paper is extremely interesting because it has a bunch of questions that were asked to expert standardization participants and expert compiler developers of how C pointers should behave. And those experts, and those are people who work on the core language implementations, in many cases got this wrong. And I think it's informative to see what the choices were, what were the answers, and why they got this wrong.
Which of the two links should I click in on?
Notes 30 full. Click on that PDF. I think it's a brilliant paper, and everyone trying to design a language based on C or competing with C should read that paper in full. It's only a few people in the world who will need to read this paper, but those people, all of those people should read it.
This is like a giant paper.
Yeah, you have a list of basically questions involving pointers. Also, it's a good paper to read for anyone who thinks he understands pointer, especially people who come from assembly language and think that knowing assembly teaches them anything about pointers in C. It's a very, very good paper to read.
Wait, what if that's our only understanding of pointers in C?
It's a bunch of questions. Just a few questions about pointers. Test yourself if you understand pointers. And they go into the language design issues.
I'm looking for, I want to see the first question. Provenance based.
Can you zoom a little bit?
I can.
One of my design philosophies is that like in C and C++, okay, there's this concept of like similar types. In my language, there's no such thing as a similar type. If I like store something as a uint 8, I can't read it back as an int 16. or sorry, int 8. Like it has to be the same signedness. It has to be the same, like the same primitive type. So you can't say, okay, well, int is similar to, or like int 8 is similar to uint 8. They're not similar in this language. They're different types, and therefore you can't alias them. So I guess that like simplifies a lot, because in C and C++, there's a lot of cases where, okay, this can alias, but this can't. And then it's like, there's so many questions. In my language, it's more like, these types are different, therefore they cannot alias. And that's like the end of the analysis, unless it's like inheritance.
Fundamentally, the C languages in general allow you to alias memory to any type.
Yeah, and I think this example we are looking at in Turbo C, I think you would have actually seen this work. So you see this example, you allocate two integers, right? Integer y and integer x. And then you take the address of x and add 1 to it, and then you take the address of y. And then there's this thing part on the right. Depending on the implementation, x and y might happen to be allocated in adjacent memory, in which case the address of x plus 1 and the address of y would have bitwise identical representation values. Then compare will succeed, and pointer derived from a pointer to x will have the same representation as value pointer derived from the object y at the point of the update where the difference p gets 11. This character in practice is GCC02 and yada yada. So this example, I mean, this illustrates the pointer provenance, because you are not supposed to be able to do this according to the standard. But I'm pretty sure if you run this on the 1990s PC with Turbo C compiler, that would probably be working out.
Okay. Also, I just checked. So C actually did not have strict aliasing prior to C99. So C++ had it from the first standard, and C added it in C99.
I don't think
that's right, but let me check something real quick.
I think C just does not use this particular wording. It's calling it strict aliasing. It's still a concept, but not called like this.
Does the C++ spec specifically call it strict aliasing? Because I thought it was just like, so in C++ or in C, it's usually just like the expression like list just has like a place that just says, these types are, if you load from an L value, these are the only things that could have been stored there, and that's what that's where it comes from. Like it's all downstream of that thing, but it doesn't ever say the word strict aliasing.
Does strict aliasing just mean you need to put in an explicit cast in order to cast?
No, it just means that like you can't cast the two pointers, that they're always disjoint. But like it's got like a funny set of like partitions. So for instance, two types could both become char pointers. But two types cannot alias each other. For instance, like two disjoint, like let's say structs, they could alias, for instance, their first element if their first element is the same type. So like if their first element is both int, they could both alias, like they could both be casted to an int pointer, and then those two int pointers could alias. But the full structure couldn't alias, and the rest of the entries, I believe, also can't alias. I don't remember exactly.
So if I have some struct and I have a subclass of it that's identical in the prefix, but it's different in the trailing bits, and I go to the first element and I say, p0.x and p1.x alias, but p and 0 and p1 aren't equal, don't alias, I'm confused.
So if it's subclasses, then they do just like alias on like the subset.
Yeah. But they don't alias on the outer pieces.
If it's a plain old data type though, because like the rule is like if it's a plain old data type and you can cast a class pointer to first member and then some other exceptions. I don't think you can cast between structs though, can you? If they like common prefix structs?
I have a
no, you can't cast between common prefix structs, I'm pretty sure, unless it's like subclasses. But if it's plain old data, the only thing you could cast is, I believe, the first element. You could cast the first element's type, and that is like a valid cast of a struct.
Yeah. Oh, you're casting
from those two
a pointer to a struct to a pointer to his first element.
Yeah. So like for instance, let's say the first element's like a tag, like an int tag.
Gotcha.
We could cast both of those into the same thing, and both of those can alias.
And in C, they do use the allowable type expression for this. So if an object has its stored value accessed other than by an end value of an allowable type, the behavior is undefined. So they just use the wording unallowable type.
Yeah, and in my language, you can't do that. So that's one of the things that I've changed. And of course that's mainly due to the fact that I have all that like, reordering of fields internally.
Yeah, but like
Yeah.
so the full rules for C are pretty short. It's basically like 6 things. It's like, the type has to be compatible with the effective type of the object, qualified, compatible with the effective type. Okay, that's basically the same thing. Let's see, a type, signed or signed and unsigned. Both of those can alias. Signed and unsigned qualified can also alias, and then aggregates, unions can alias with their sub elements, and then character types can alias with everything. So char,
There's also
unsigned
this.
char, and inside char.
I think you're also allowed to use this common initial sequence rule, right? That was like for C sockets in the networking code.
Yeah, it
So
looks like there's
that's not mentioned here, but like it does. I'm pretty sure that's true. I just don't remember where that's mentioned.
It seems like there's a lot of like undefined behavior in that paper that it's looking at, because I saw that thing where it's like comparing a pointer past the end of an array and stuff.
Yeah, and there's a surprising amount of people, and again, they interviewed experts working on compilers and the standards, and many of them got this wrong, many of those questions. So it gets kind of surprisingly subtle.
Yeah, because like I think it's undefined to compare pointers from different arrays or something like that.
So you can't get pointer difference across two like memory objects, quote unquote. You also can't do I believe that's the main one.
You're allowed to do one past the end comparison, and this is for the for loops, like you want to see whether you are done traversing the array.
Yeah. Yeah, but if you took two separate arrays, you couldn't like get the delta between them, because technically C doesn't have to make that a materializable concept. And there's a few subtle ways in which that happens. One of them is like you have two things at the very ends of the address space, and they're just too far to represent like as a signed distance correctly without overflowing. And so like there's like a subtlety there technically, and a few other random cases like that.
Yeah, this is also
compiler to enforce that. Does it have to keep around tables of what pointers or what types at runtime, or can you do all that?
No, it enforces that by UB. So it just says like the abstract model is allowed to assume this, but it's not going to check for it.
Yeah, and this like shows up in compiler optimizations where it'll like elide something to be false, like that comparison. If you bring back up that example where it was like, okay, this is false, but in reality, when you run it, it might not be false.
There's also interesting carve out in the C++ standard for stdless, in that you are actually allowed to get two arbitrary pointed arguments in the stdless. And what it says is going to happen that if this type is a pointer type, the result is consistent with the implementation defined strict total order over pointers. The total part is the important part, because total means any two pointers are comparable, but the result of comparison is implementation defined. Which is interesting, because that stdless has an explicit carve-out in the standard to allow you to compare arbitrary pointers. Which kind of brings the question of separation: what is the standard library and what is the core language?
Right.
And that's even before atomics. I mean, atomics really did blur the distinction, but stdless even before atomics was interesting.
Yeah, I think that's also a little bit of a problem if you want to like create a map of pointers, and like how do you define, I guess, relative pointer comparisons?
Yeah, you need to use stdless in the implementation. That's exactly why you see libraries like standard library and boost, and probably LLVM and others use things like stdless, because that's legal in general.
Okay.
Life's a lot easier in the Java land. Fine.
I would say if you allow the aliasing from a different type in a narrow scope, that would be easier.
You again got
Again,
quiet.
okay. I would say that if you allow the aliasing in a narrow scope, the implicit conversion, let's say inside only a function, if you have a source designation that only inside a function the ubyte, the uint and byte are convertible and do something with them, and nothing is allowed like that outside of the function, would be much more easier, or no?
Boy, dude, you had a fancy mic in front of you, but you are not. Thank you for your cat butt. You're not being audible.
Yeah, and this actually creates a little bit of a problem for me because like I was saying, okay, well, if a type is a data type, it creates like a single total order. So like, how do you do that with pointers? Like, you can't create a total order if things from different arrays aren't comparable. So like, do I break those optimizations or do I do something else to like mitigate that?
Just say you don't get a total order on pointers.
But then you won't be able to store them in container or sort them.
If you, yes, right. So suppose I want to demand that they're, well, if you put them, okay, so this is a different one. So as soon as you say I have a pointer that's in a container, then you said it has a
Not a
promise.
container like std map, for example, which is a red-black tree and requires the comparison operator for keys.
Yeah, but then, okay, I can't do garbage collection. I can't move pointers. Restate that. I cannot move pointers via like a garbage collection then.
Yeah, exactly.
Yeah. Deny the less than, so I can't use a red-black tree because the pointers change. I claim that's a reasonable trade-off. There's an easy way to say that I want to sort two things. I'm not going to use their pointer values to sort them.
Yeah, I think that does create problems though, because sometimes you need the pointer values to do like different data structures or like dealing with memory allocations or various things where you don't want to like duplicate the object every time, but using a pointer is a good enough representation because its lifetime is bound to the scope of some operation that you're doing.
I think that's unrelated to whether or not I rename them and get to ordering.
Well, what I'm saying is like, if I want to create a map, like let's say I want to store some metadata about, I don't know, like how long a struct has been alive or something, and maybe that goes into a map, I could just use the address of the struct, right? But that like requires
go find
the
the
total order.
There's a different rule that says if I have a pointer and I throw it in a table, a map, and I want to use it as a key and then pull it back out, and I'm doing garbage collection, that all works fine in the Java land, but it demands that you have a hash and a quality check that are not necessarily they have a hash and quality check that are invariant to garbage collection, and the default standard system hash is, and the default pointer quality is. It's literally pointer quality. So I can put them in a hash and have garbage collection. I can't do it with a red-black tree.
Oh yeah. That's kind of, I guess, a secondary topic. It's like if you're moving objects around and changing what their pointer is.
Yeah, changing the actual mechanical the pointer value.
Yeah,
numerical representation, but be careful with comparing with numerical representation because you may still have multiple address spaces like with GPUs. The old example would be x86 segmented memory, but today I think GPUs are the more common example.
Yeah.
So like, here's another question though. Like, what is the situation where you get an optimization out of saying that two pointers out of different objects cannot be equal? Because that's like maybe like an overlap check, but like, what other situations are there where you can like do that optimization and get a performance benefit? Because I'm wondering if it's like optimal to just like
two pointers not equal, or
so like if we say that the pointers from different arrays can't compare equal, right? Then I'm kind of like wondering, what is the situation where saying that as an optimization rule, or where like the behavior is undefined, where does that undefined behavior actually give us a performance optimization, and is it worth keeping?
So there is a list of the assumptions in the basic AA pass, and you're gonna see the list like distinct globals, stack allocations, and heap allocations can never alias. So those distinct allocations, that's it.
Yeah.
That's the one that allows you to do the basic alias analysis.
Yeah, I'm pretty sure it's just downstream of like, so if you did a pointer offset, let's say like, oh, you did a array index or some pointer adding, that can't reach across a memory object. So you couldn't go from like one heap allocation to a completely distinct one. The compiler doesn't have to guarantee the distance between them. It doesn't have to guarantee that it is like a meaningful thing to go like to derive another allocation from it. And then the inverse is also true, which is like, oh, if you subtract pointers, then they also can't reach across objects. And the whole point is to say, like, if you want to reach into a memory object, you have to refer to the memory object directly. You need a pointer that's in the memory object. You cannot just like derive one. And then that's like downstream of other aliasing stuff.
Yeah.
So like for instance, like the simplistic example is going to be like local variables. The compiler is allowed to put local variables into registers because it's allowed to say, hey, if you don't directly refer to it, nobody else can. Even though it's in memory, and in theory, you could make a pointer difference that could let somebody else refer to it. Technically, that would be UB. The compiler is allowed to say, no, you have to directly refer to it, or else I'm allowed to assume it's not being referred to.
So do I just
Or
say
like-
that pointers are not totally ordered, and then, you know, if we want to total order pointers, we convert it to, I don't know, like uint pointer, and then we have a total ordering?
Yeah.
Yeah, although even that gets scary when you have metadata in your pointers.
Yeah, address spaces. Again, remember about address spaces.
Well,
Well,
assuming that
address
you're-
space is one, and the other one is like metadata, like cherry. Like two pointers might look the same. And, yeah, like they might not order nicely, and then yeah, address space as well.
So what are the situations where we have metadata and pointers? Like, I'm curious about that. Like,
Cherry does, I think, 128-bit pointers, and it's for like safe native stuff. Let's see, it's like a hardware extension to make chunky pointers that allow you to do fancy like bounce checking at hardware. It can keep track of like where the memory object starts, how big it is.
Please,
And
can you
some other
share one thing on the screen?
Yeah, the far pointers. I live with.
It's a beautiful example. That is a bit crazy, but it may be good for Ryan to think about.
This one, far pointers.
Yeah, the example of far pointer. Look at this. So
Yeah,
You can get a lot of compression out of having a
You have
distinction
one pointer
between small
P.
pointers and long pointers.
Let's let Matt finish his example.
So look at it. Maybe just zoom in on this code and the explanation after that.
Wow. Okay. So somebody ate my Control Plus to scroll. And
You can just click large on the text on the right hand side.
Okay.
should I create like a new type called like
Yeah.
p-ord or something like, okay, so let's say I have this like type and I call it p-ord or pointer.
Hey, hang
order.
on. Yes, Matt was trying to work through this, but
And
this is
slow
the
down a
thing.
little bit. You have those 2 pointers that look like they have different numeric values, right? You have pointer P and pointer Q, and they seem to refer to different addresses. And then you write through P 80, and then you increment through P, and then you print Q, and it turns out that Q is gonna read 81. And that's because they point to the same location, and then you have this calculation that you have to adjust by the offset and by the segment. And when you do this, you can see this calculation, they actually point to the exact same location, hex 55555. So those are actually pointing to the same memory, even though their numeric values are distinct.
So
that's a
argue this is
example of this metadata that Yasser was talking about. This is nasty, I would say, but...
Right. I would argue that this is like not a thing that you want to make your language semantics around. This was x86 having a continuously overlapping set of actually addressable memories with a wide variety of addresses, a huge count of unrelated pointers pointing in the same shared memory.
I guess what I'm asking here though is like, should I have a type like p-ord, which is like you could convert from a pointer to this p-ord type, but not necessarily back, or maybe you can convert back, but it has some kind of restriction.
No, I think that's a reasonable thing.
Yeah, that's how I'd approach it. I posted a link to the Cherry stuff. You can see a description of like what the pointer looks like. It's basically got like permissions. It's got, I believe it's tag permissions. Tag permissions, types, bounds, and then the address itself.
Yeah, I'm wondering because like one thing I do want is like to be able to like look up something by its pointer in a map, and like I'm wondering like what are the situations where 2 pointers of the same type compare like equal but have different memory values, I guess. So that's kind of like
You essentially want to use pointers hash.
and like should if there is different metadata flags, should they compare equal, or should I say oh these are actually like what's the situation? Like do those compare equal even though they have different memory values?
In cherry stuff, if they like point to the same thing but have different metadata, then they would technically not be equal. But I don't think you're supposed to make pointers that way. The whole idea is that you pass around the legal one definition of the object, so like the type stays the same for everyone. Should be staring at the same type. Although I think you can cheat that. I'm pretty sure you can cheat that.
Yeah, I'm just wondering.
Huh. Yeah, this thing is hard.
That's why I recommend this paper again, because I'm pretty sure that one of those many questions is going to have multiple examples of that going bad or wrong. And I would not claim I know this from memory, so that's why I that's why I refer to the paper. I do think it's hard.
So I guess I'll just say that pointers are not data types, and then we have to have some sort of similar type that we convert pointers to.
Seriously, I'm serious. Try working through all of those examples and the questions and decide how you want this to work in your language. And I'm pretty sure you're gonna have a design falling out of this if you do this exercise.
Yeah, there's not that many questions, and I think they'll pretty quickly refine your thinking on what you're trying to do.
And this is the paper about pointers, or
yeah, the one with the full of questions about pointers. See memory object and value semantics, the space of de facto and ISO standards.
So I guess the links number 7 is where's the questions one?
There's quite a lot of links in chat, actually.
Yeah, this is a huge kind of links today.
Yeah. Maybe we can go ahead and put those in the doc, and I'll take a look at them later.
They're all there. I'm trying to find the one that Matt had the questions, which I thought were really nice. Notes full standard, maybe this one.
Yeah, it is the Notes 30 full PDF for what it's worth.
Not the one I just went to. Sorry, say again. It's
Notes 30-full.pdf.
This. I just went to that. Notes 30, yes. Am I confused? Oh, I'm looking for the one that has the questions. I thought the questions were fun. Where's the question one, Matt? The 27,000 question one. No.
That's the one. You're not seeing your screen, so I cannot see if that's the one you're looking for, but it should be just one.
Oh,
Yeah.
this.
Yeah.
Probably. All right, I give it up. I'll find it later. I'm dragging things here. I keep clicking through one of 2 different things.
I think it's the one Matt ordered because it starts with the
Here it is. It's
question one.
notes. And I went to N322 and it's notes full text. Okay. Yes. All right. And now going back to the docs, except I can't go back because too many windows. Going back. Wow. It's exciting. Yes. This window, wow, it won't go to the top. Holy crap, there it went to the top. All right. Something weird going on here. The notes, the de facto standard notes one. All right, done. Well, I might wind it down here unless we have something else we want to talk about. I want to poke PG&E because they haven't sent me a nasty text saying your power's out and we know it, which means maybe they don't know my power's out, which means it's not getting fixed. So I need to go deal with PG.
Did you see this Gluon announcement? I thought that was interesting.
Which one?
Gluon, that language that is in the same compiler stack as Triton, but it's a little bit lower level.
Right. Yes, on my to-do list to go read. I saw it roll by. You put that in Discord. Let me find the Discord channel. Just back a little ways and said, basically, the auto do everything compiler technology wasn't working. We had to go back to letting programmers hand hack things. And then
Yeah, the motivation was that they were claiming that they are bound by 80% peak performance or speed of light performance with the Triton as is. So they did need to have a lower level language that gives more control to the developer.
Right.
And control means like the layout assignment, word specialization, synchronization, that kind of stuff.
Right.
Which is kind of interesting because that may be a commentary of how hard it is to have a portable peak performance at least.
That's the modular mojo take on life. All these programming languages for GPUs have issues, so we're going to give you more control. In particular, Graphit does a thing, and modular folks want to say that they're going to do something, be able to do that kind of thing. Whether or not their technology stack is better or worse than Graphit's different, but they're definitely saying programmers are writing things that do rewriting of the graph layouts as an automated tooling, because the treating it as a lower level problem is you can't, you're too low level. You need to start from the high level graph view and then start restructuring.
I have been wondering more and more whether it makes sense for programming languages to draw a clearer distinction between an object that represents a layout versus an object that really is just data abstraction. Normally, when I make a struct, I don't really want a struct. What I really want is a namespace that has these type things in it. And I don't care how you lay it out.
Right. And there is a layout the compiler picks. Right.
Right. But if I have an array with a billion structs in it,
yeah,
that implies a layout.
Yeah.
But usually that's not really what I mean. What I mean is I want an index space that has a billion namespaces in it. And if you under the hood want to change that into a column store,
right, let's say struct
great, it runs faster now.
Yeah. Right. I mean, that's what H2O's model was. We gave you the illusion of a billion structs, but
how did you represent that? People made a class for each of the rows.
We live within the language of Java. So you had a data frame object, imagine pandas, and you could treat it as a struct with a collection of columns that were named a namespace and an element offset and a billion rows. Because it was like a data frame, it wasn't a compile time strategy on the layout. You could add and remove columns. You knew secretly under the hood the columns were going to get columns stored on you, but you still treated it like it was a namespace. But the namespaces had...
Yeah, I think if I was starting a language today, I would reverse it. And rather than having arrays and structs be kind of fundamental in-your-face objects that the whole standard library is written around, I would make the data frame the thing that was the in-your-face object that the whole data frame is around.
Right.
Structs and arrays is just the thing you reach for in the serialization library.
Right. So the guarantee we gave you on performance was that if you used columns, a fixed set of named columns in a hot loop that said for all rows, we would pull the column lookup out. So it wasn't, you didn't have to have some sort of conversion of a field to an offset within a struct. We would pull the column out and out of the loop, and then the body of the loop would let you walk over the elements in memory bandwidth speeds.
Some of this may be kind of hard to express in a higher level language, but doesn't mean it's not possible. Also, like in Halide style user schedulable language. For example, I mean, both for the Gluon and TLX, which is another Triton low level language extensions, one of the motivation is warp specialization. So on modern GPUs like Blackwell, you can actually have different warps, thread within a warp have different roles. Like you can have one load some data in the kernel, the one can compute, the other one can store. And that turns out to be relatively hard for the compilers right now to reinvent from a high-level code. So at least that's one of the motivations, one of the optimizations that motivated Gluon in addition to Triton. That's also motivating TLX. I also posted a really good blog post that Rohan Yadav wrote on weaving warp specialization that motivates this. And I do wonder actually how easy would it be to have something like schedule language like Halite or the Graphite we talked about earlier, that could be able to break up your kernel and perform those optimizations for you. Maybe not trivial, but would be very interesting because that would actually allow you to have higher level programming language model. Just you don't want this to end up like somewhat auto-vectorization ended up in C or C++ when it can be brittle. You would rather have it like auto-vectorization in Fortran where you can always rely on this to work. And that by itself may be a difficult balance to achieve.
The modular one is basically they've got a DSL for doing layouts and scheduling on GPUs written in the Mojo language that does the, guaranteed inline and unroll and fix everything down to a constant. So that's going to be the actual schedule on the GPU. But the DSL has some shared things and then some special things for Blackwell versus AMD this versus NVIDIA that. Because they do require different layouts. I don't know. I think it's currently an open researchy topic that is actively being researched by many industry people because the amount of money being spent for AI.
Yeah, latent parallelization and data movement optimization, like you can have different granularity at which you can break up your model. Like you can have data parallelism, tensor parallelism, expert parallelism, and different layers of this parallelism require different latency and speed on the interconnect. Now you can do a lot of traffic if you have something very fast like NVLink between 8 GPUs that are linked in one node. But when you have to go between the nodes, you might have to use some cluster interconnect, like think of InfiniBand or even Ethernet. That's much slower. So there's only different kinds of data. You wouldn't want to do all kinds of parallelism based on that because the data movement cost would overwhelm any gains you would gain from parallelization.
Right.
And having compiler think of that kind of stuff, take a naive kernel and automatically parallelize this and optimize data traffic, data movement, that could be non-trivial, but also very interesting.
Yeah.
I mean, non-uniform memory access is not a new problem.
Yep. Just more and more non-uniform and more heterogeneous.
It's not even non-uniform in the sense that you have a common shared address space with different costs to get at. It's the unrelated address spaces. Yeah, H2O acknowledged under the hood that there were two tiers, right? There's within a node and across a cluster, which went to Ethernet. We could hide it if you had bulk synchronous parallel, and if you were doing some other form of parallelism, you basically had to deal with it yourself. We'd help you cross the Ethernet, but not design an algorithm that would take advantage of the differing costs.
I mean, did you have examples of where H2O cried?
H2O what?
What were the examples of memory access patterns H2O did really badly at?
Oh, badly at. So anyone who wanted to do go across the Ethernet on too fine a grain was going to have it. So we started Random Forest by building each. So the defining characteristic of H2O was the data was too big to fit on a node. We're going to put it in RAM. So you hadn't had enough RAM, so you had enough clusters to hold the data in memory. Okay, so there's no disk I/O. It's all memory based. But not every node has access to all the data. So the first cut for Random Forest was every node builds a tree, but they're building a tree on the subset they have. this turns out in practice to build very weak trees because they don't pick up on the long tail distribution because all the other nodes have rare things that are interesting in the long tail distributions. You got a poor fit for data sets that didn't have a very obvious solution. So then we said, okay, run over the wire to go get summary data from everybody else. And as the random forest trees start at the leaves and there's a histogram being computed of which way you're going to split, you got a small count of data that was highly summarized, which was okay. As you got down toward the leaves, you had to have separate histogram buckets for each individual tree leaf. And the deeper the random forest got, the smaller the buckets and the more distributed they went. And you drowned in network traffic trying to hand a million buckets, which all contain the sum of 10 things or something. So deep trees that spread around the cluster were expensive to build. And shallow trees were fine. And so you wanted your random forest to be limited in depth. And then, so that was, a case where the algorithm didn't fit well. We did gradient boosting machine. The original algorithm was considered unparallelizable. We did it the way that we did it, talked about here with random forest, except that the nature of the depth of the trees was there a lot shallower. And so you didn't get drowned in the network traffic. Otherwise, pretty good. We didn't have to do tiling, so we weren't doing two-dimensional or n-dimensional things. It was always named columns by row, which meant that you weren't doing tiles of columns, which we would not have done tiling things for.
So if Mojo wanted to help solve similar problems,
like
the best strategy
sorry, go ahead.
would probably be just to provide a standard library of techniques for doing common things in ways that divide up nicely.
Right. We provided standard libraries for a bunch of things, including things like I want to count uniques across the cluster. So there's an efficient way to go get uniques across the cluster. Bunch of things that went around the cluster we had easy, short, calls for. But if you had a distinct, different data access pattern, so anything that looked like a for all rows kind of operation you were all happy with. What was another good example? Like ADMM was basically matrix multiplication done for linear regression, the linear algebra things. If your column count got too wide, you started to not work as well. And that was because we weren't tiling. So an ADMM kind of thing, it's matrix multiply, but with named columns, which was great for dozen, 100 columns. And 1,000 columns started to suck because we weren't going to tile. And at 10,000 to 100,000 columns, we're not any better than anything else. And past that, you wanted to rethink the problem and go a different way. So this is why, like NumPy, which is all matrix things, is going to tile on you, would win after a certain point of width. And we were winning because of the compression for the columnar compression if you were skinny. So data sets that were trillions long and 100 wide were great on H2O. And data sets that were 1 million wide and 1 million long were not great. Okay. I'm going to call it. Been an exciting go around. We've done a lot of good ones in a row here. I have. What's today? The 19th? Yes. I'll be in an all hands with modular next week, so no CCC next week. Some point down the road, I know Jinjavin. God, I cannot see your name.
Evgeny.
Evgeny. Not doing it yet.
Evgeny.
Evgeny.
Wants to talk more about his compiler, which I think would be a cool CCC. But not next week. And I'll talk with him about scheduling it. Might be soon thereafter. That's it.
Okay.
Anything else? Gonna call it.
I'll throw a few like random scattered updates. So in the last like few weeks and or months, let's see. I redid my DSL for instruction selection. Yeah, I'm planning on throwing more things into the DSL, mostly like the register like constraint stuff, and then a few other random bits. But I haven't done that yet. I did describe out like how to do like the pipeline hazard detection stuff because I read some paper on GCC on like how they convert it to like a DFA. Except the DFA one seems a little scary because once you start getting like multi-issue sort of things, then you have like multiple states that are like, hey, this is like we're using 3 of the ALUs. And it's like actually this one's using 2, and then it skips one and then uses the other one, and then like all that leads to like a bajillion states. So I don't know how far I'll take it, especially considering that out of order processors kind of handle a lot of that bulk for me. So I probably don't care about them too much. But for the VLIWs and in order processors, they probably really value being able to like hide latencies, especially.
This is like its own CCC topic here. I mean, you could go on for hours.
Yeah, well, that's things I'm exploring. I haven't gone too far into that. And then I read some papers on like pipeline hazard stuff on like doing collision matrices.
Here's the thing: the expected performance win on these, on an x86 or any of these sort of modern phone and laptop pieces, or versus embedded, they're wildly different. And if you burn a lot of time and energy that doesn't play into whoever your common target is, I made this little tiny embedded guy go 2x faster, but it did shit for x86, which is just wildly out of order and doesn't really care. Horseshoes and hand grenades, close enough, you're done.
So for me, I do have some embedded targets, especially ARM, because like every other ARM chip is like some like really shitty like in order processor that like takes 1 watt.
For a little, you're not talking about like the Apple Mac ARMs. You're talking about
no. Yeah, most of the ARM processors I run into are like I think half of the processors on my phone are in order, and then the other half are out of order.
Fine. Okay. Just saying. Don't burn too much time and energy for.
I read an interesting comment that in LLVM the fallback model for ARM is actually the in-order one, because in order one it's really intolerant to bad scheduling, but out of order, whatever, you can just use in-order proc. So that's the fallback model.
All right. I'm going to call it. More updates the next go around is also fine, Yasser.
Yeah, I hopefully will have new fun things because I've been like exploring a few other things.
Yeah, and you can throw out slides or pictures or code examples and stuff too, but not at 3 to 12. I have things to do. In particular, I need to call PG&E up and like yell at them. Hey, where's my power? All right. Next week. No, 2 weeks. 2 weeks. Next week I'm out. All right. Bye-bye.
Have a good weekend.